So to solve this type of cubic equation, we need to use the rational theorem, rational zero theorem. And here we need to guess one root by trial and error method. And for that thing, we can use some rational numbers, which we get by dividing p by q. So p by q, where p is a constant, last constant number, by q is a quotient of x cube 3. So what will we do is, we'll write factors for 24. Remember, the first number you have to take is 24, which is constant number. Assume it as some p, and we'll write factors for 24. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, plus or minus 24. So 24 is divisible by 1, 2, 3, 4, 6, 8, 12 and 24. And for 3 we have factors as plus or minus 1 and plus or minus 3. So when we divide p by q, so the possible solutions are plus 1 by 1, plus 2 by 1, plus 3 by 1, plus 4 by 1. That means all will come plus or minus 6, plus or minus 8, plus or minus 12, plus or minus 24, and plus or minus 1 by 3, plus or minus 2 by 3, plus or minus 3 by 3, plus or minus 4 by 3, plus or minus 6 by 3, plus or minus 8 by 3, plus or minus 12 by 3, and plus or minus 24 by 3. So these are the possible solutions which we can directly substitute and check whether they are actual roots or not. Okay, so let me start with 1, f of 1. So 1, 3 into 1 cube minus 5 into 1 square minus 22 plus 24. So it will be 3 minus 5 minus 22 plus 24. That means minus 2 minus 22 plus 24. That means minus 24 plus 24, which is equal to 0. So that means for 1 we are getting 0. That means 1 is a solution, or 1 is a root of this cubic equation. So we have to use synthetic division after getting this one, and then we'll find other two roots, because a cubic equation will have three roots. So the first root can be find out by rational zero theorem by using this technique. Remember, the first root is always checked or always confirmed by using rational zero theorem, and this theorem says we need to divide p by q values, where p is the last constant number and q is the coefficient of the highest degree value. So we'll let factors for all the numbers, and we will check each and number each and every number where it is becoming 0. Here interestingly we got f of 1 as 0. That means 1 is the 0 of this equation. So we'll divide this polynomial with 1 by using a concept called synthetic division, and we'll find remaining two roots. So now I'll tell you the process of doing synthetic division. In synthetic division, we need to write only coefficients of the given function. So 3 minus 5 minus 22 and 24. 3 minus 5 minus 22 and 24. And we got one root as 1. So we will divide with 1. The first number is always 0. So inside bracket we have to do addition, and outside we have to do multiplication. So 3 plus 0 is 3. 3 ones are 3. Minus 5 plus 3 is 2. Minus 2, and minus 2 ones are minus 2. Minus 2 minus 22 is minus 24. Minus 24 ones are is minus 24, and the answer is 0. And the answer is 0. Okay. So now we'll just put x square here, x here, and the constant here. So this will be 3x square minus 2x minus 24. So now it is reduced into a quadratic equation, and we know how to solve a quadratic equation by splitting into middle term factorization. So it will be 3 into minus 24 will be minus 72. We will write factors for minus 72. It will be 1 into 72, 2 into 36, 3 into 24, 4 into 18, 6 into 12. Then that's it, right? Yeah. So you're not getting any root here. Minus 72, 1 comma 72, 236, 324, 418, 612, 8. 8 nines are 72 and 6, 7, 8, 9. That's it. So here the question is 3x square minus 20x. Yeah. So So we'll solve this quadratic equation again by using rational theorem here. So we'll substitute some of the values here, 1 by 3, 2 by 3, 3 by 3 like this, and we'll solve this quadratic equation.